Hey everybody, Trey here. Welcome back to another forecast discussion. We haven't talked much about current severe weather events on the channel in a while, but that is going to change today as we have a slight risk out for parts of Oklahoma into North Texas. Level 2 out of 5 slight risk, and we are certainly kicking off our secondary severe weather season here in the plains with a bang. All hazards on the table for today, with the greatest threat being large to very large hail. There's a 15% hatched area in that yellow stippled area there from northern Oklahoma into northern Texas. That does include places like the entire Oklahoma City metro area, Lawton down to Ardmore, and the very western and northwestern sides of the Dallas-Fort Worth metroplex under the gun for that greatest hail threat today. Potentially some hailstones above 2 inches in diameter. Damaging wind also going to be a threat. We do have that 15% area there within the main slight risk for those areas from northern Oklahoma into North Texas. And there is a tornado threat for today. There is a 2% tornado risk out centered on the Oklahoma City metro area and places like Enid, Stillwater down toward Oklahoma City, then Lawton and the I-35 corridor toward Ardmore. So there is a tornado threat today. It is a bit on the conditional side. We'll discuss why here in just a bit, but it is all in all going to be a pretty active day across the region, with the main threats being large hail and damaging winds. So let's go ahead and dive right in. This is our water vapor satellite imagery, and basically we're looking for the swirls, and that represents the location of our troughs. You see a big swirl here out across the northeast. That is the trough that kind of sucked up former Hurricane Lee, pushed it into Nova Scotia last week. But other than that, not seeing a whole lot of action here across much of the country. Mostly zonal flow, west to east flow here across much of the country, with the exception maybe across southern Colorado into northern New Mexico. Maybe a little bit of a perturbation there, and it's going to show up better when we look at our upper air maps. And you see all of these greens here across Kansas, Oklahoma into North Texas. That is a batch of thunderstorms that has been ongoing this morning. I was woken up very early here in Norman by some pretty frequent lightning and thunder. With very intense thunderstorms this morning. Nothing severe, but some heavy rain, frequent lightning and thunder was a nice wake-up call this morning. We look at our radar to show you that the activity that it continues to propagate this morning across Kansas into Oklahoma and far north Texas. This batch of storms is expected to continue through the morning hours, and we are expecting to see possible redevelopment on the backside of this morning batch. That is due to a little bit of a complex pattern within that mainly zonal flow in the 500 millibar pattern. We'll show you that in just a second. But this is going to have a big impact on what happens this afternoon, especially across the northern portions of the outlook area. Oklahoma, as we saw, was under the gun for the greatest tornado risk. That is all going to be dependent on how much destabilization we get after these early rounds of storms. Again, we're expecting a bit more storm activity behind this main wave, as some of the models show, and based on what the 500 millibar pattern shows. We'll show you that in just a second. But that's going to be very much a key to what happens this afternoon. If we have more storms early on, we may not be able to destabilize as much, and therefore a less robust severe threat farther north. If we have less storm coverage later, going through the morning and afternoon, then we'll see better destabilization, better chance for robust storms across the northern portions of the risk area. Farther to the south across North Texas, we don't see as much activity. Not going to be as much in play with the shortwave that we're going to talk about here in a second. So we should see a better chance for full destabilization down here. Temperatures should warm a little bit more than up here in Oklahoma. So I'm not as worried about that farther to the south in Texas. We should see a few robust storms down there as well with a hail and wind threat. But Oklahoma, again, the question is going to remain what happens with this early activity. You see the satellite presentation as well. We do see quite a bit of clearing behind here, but once again, there is a little bit of a wave back in here as we saw across southern Colorado. We're going to show the 500 millibar map in a second. But we do have lots of clearing behind this early round, so it's going to depend on how much activity redevelops behind this early batch across Oklahoma in the coming hours. So here is the 500 millibar map as promised. This is at 14Z, so as of 9 a.m. Central Daylight Time, the very latest run here, latest observational map here of the mesoanalysis. And you see mostly zonal flow, east-west flow across much of the area. You see these little ripples in the flow. Those are shortwave troughs, little kinks within the main flow that are little enhanced areas of lift and favorable ingredients for storm development that are going to be passing through western and central Oklahoma, going through about midday to early afternoon. When we have a little bit of enhanced lift with this shortwave here, that is possibly going to set off another round of storms behind this morning activity. So we're going to have to watch that closely. It should be somewhere in western to central Oklahoma by about lunchtime or so, and we'll have to see if that initiates a round of storms. Now, there's some more kinks behind this one. You'll see this a little bit better when we go through the model runs. The latest model runs for today show you a little bit better of a progression of how this pattern is going to evolve. There are just a lot of kinks in the flow here, and this first kink that is going to pass through about midday or so, if that sets off a round of storms, that is going to leave questions for the main round of storms in the afternoon. Now, that is because on the backside of these short waves, on the leading edge, you have lift, favorable forcing for ascent for storm development. But on the backside of these short waves, you have what's called subsidence or sinking motion. And of course, sinking motion is unfavorable for storm development. We want to see that rising motion to get storms to go. So on the backside of short waves, there is sinking motion. And so as this first shortwave passes through, we may see a little bit of subsidence on the backside across western and central Oklahoma that may negate a lot of storm coverage in the afternoon. Also, we're going to have to be worried about that secondary round of storms that may develop on the backside of this morning round. That is what is leading to a little bit of conditionality in the threat farther north. Again, farther to the south, we're a little bit farther removed from that shortwave trough and the morning convection here. So across North Texas, I'm not too worried about robust storm development down there. It is up to the north across northwest Oklahoma into central Oklahoma where the questions reside. But given that we have more kinks coming through, a little bit of a secondary shortwave moving through by about mid to late afternoon or so, that should negate that subsidence we talked about from the first shortwave, but again, that destabilization is going to still be in question. Now, given that we don't have a very strong, deep, digging, highly amplified trough here, we would not expect to see a robust surface response, and that's exactly what we have going on. Looks like a little bit of a frontal zone here stretching from southern Canada down into the plains, out here down into northwest Oklahoma, into the Texas Panhandle. You see the pressure tongue there. That is a classic sign of a frontal zone, probably a cold frontal zone from a surface low up here somewhere in Canada, maybe just off the screen there. So a little bit of a cold frontal zone possibly there. Shouldn't be moving too much. Again, not as robust of a surface response. We probably will see a little bit of a response down here given the track of these short waves here. We probably will see a little bit of a tightening of the pressure gradient here across the Texas Panhandle, with a warm front extending out to the east of what could be a little bit of a surface low that develops in the Texas Panhandle. We'll show that on some of the model data in just a second. So we should have a little bit of a surface low out here. Nothing intense as far as surface cyclones go, but a little bit perhaps of tightening of the pressure gradient there, a little bit of enhanced backing of the winds out there, out ahead of it, especially along the warm frontal zone that should set up somewhere in north central to central Oklahoma today. That will represent the leading edge of the moisture return as well. So again, we're going to go over that in just a second, but that could be that come into play, and that's why we have a tornado threat farther to the north, because winds should be a little bit more back closer to this weak surface low that develops. A little bit more back, stronger surface flow there is going to enlarge those low-level photographs for possibly a small window of tornado potential across northwest into central Oklahoma. Farther to the south, a little bit more removed from that little surface low that may develop. And actually, I'm going to just go forward a little bit. Few hours, you see a little bit of if you focus there in the Texas Panhandle, a little bit more of curvature there, a little bit of troughiness there at the surface. So a slight development of maybe a weak surface low down there in that vicinity with a little bit of strengthening and backing of those surface winds should provide a little bit extra oomph there for the wind profiles in Oklahoma as opposed to North Texas. So the tornado threat should not extend past the Red River. I would suspect should be mostly a hail and wind threat down in northwest Texas. Up here in Oklahoma is where the tornado threat would be, but there are still some caveats with this tornado threat, and we'll talk about that in just a second. So let's go to our actual surface data here to see what is going on. You see mostly southerly flow across the southern plains. 50s, upper 50s to 60s dew points here. Very patchy 60s dew points. Again, we haven't had a preceding system or two to really get that moisture to return into the plains. Not that very supple surface moisture that we often see late in the springtime. We have mostly upper 50s, mid to upper 50s with some 60s dew points, kind of patchy within the Oklahoma-Texas vicinity. If we look at our Oklahoma mesonet as well, you see patchy 60s across the area, with the highest values here in southwest Oklahoma, 63, 64, and some patchy 60s otherwise, 61 degree dew point there at Norman, with some here up in the northern portion of the state. So very patchy 60s dew points, not that very supple surface moisture that you would expect with a significant severe event, but it should be enough to provide a robust severe threat for today across this region. Now you see where that frontal zone looks to be located. Westerly winds on the west side of that front across the Texas Panhandle into the Oklahoma Panhandle. More southerly winds here across western Oklahoma. So your frontal zone, your cold frontal zone, probably somewhere in there. And we are expecting a dry line to set up somewhere in this vicinity as well. Perhaps a merger of the composite boundary between the dry line and the cold front. But there should be some sort of moisture boundary here across the Oklahoma-Texas border vicinity. Better moisture going to reside here to the east across Oklahoma and North Texas with 60s dew points in that area. We could possibly see some daytime mixing as the sun comes out. We could see some mixing of those surface dew points. So if we do get 64, 65 dew points up in here, don't expect those to hang around all day unless cloud cover sticks around a little bit longer than expected. That is one positive if you're looking for severe weather, if you're a chaser or whatnot. If you're looking for severe weather and we get 60 dew points up in here, but those clouds from the morning batch, those early batches of storms stick around a little bit longer, that could provide an opportunity for mixing to stay at bay up here to the north. Keep those temperature dew point spreads down, which is another question with the tornado threat here up farther to the north. And we may see a little bit better of a tornado threat if robust storms can fire. It's kind of a double-edged sword. If that cloud cover hangs around, dew points will stay a little bit higher. Those temperature dew point spreads will stay down a little bit, increasing the chances for tornadoes, but also that may put a little bit more of a pause in storm development if those clouds stick around, as destabilization may not be full as it would be down here in northwest Texas, far southwest Oklahoma. All right, let's look at some soundings here. We did not get a Norman sounding from this morning because of some ongoing thunderstorms, so we do have a Lamont sounding from northern Oklahoma and a Dallas-Fort Worth. Let's start with Dallas-Fort Worth to show you that we do have at least decent moisture at the surface, 59 dew point there at 12Z, 7 a.m. Central Daylight Time at Dallas-Fort Worth, but that moisture quality is not the best. Usually you like to see that moist layer with that green profile, the dew point line, and the red line, the temperature profile as you go up in the atmosphere, to be very close together here in the low levels. That is not the case. We see kind of a weaker, a more modest moisture quality here, even though the surface dew point is somewhat high. The moisture quality is a bit low. So that is perhaps a concern for today and will allow those temperature dew point spreads to get pretty high as that drier air can mix down to the surface a little bit in areas that receive full sunshine. Other than that, a little bit of instability here this morning. That's what is supporting these thunderstorms. It is elevated instability above this low-level capping inversion. And we do see some fairly steep lapse rates here across this region. You see a little bit maybe of an elevated mixed layer somewhere in here. Not super noticeable, not that real, strong warm nose that we often see, but here about 700 millibars or so, we do see a little bit of a warm nose there with some drier air aloft, representative of an elevated mixed layer that has been transported and will continue to be transported out here to the east from those higher terrain regions out to the west. That elevated mixed layer, we always talk about it on that channel. It's that warm, dry, well-mixed air that originates from the desert southwest, western Mexico, and the higher terrain out west gets transported out to the east on the westerly mid-level flow, and that can help cap the atmosphere going into the afternoon. Now, this cap is not all that strong, so we've seen some elevated thunderstorms this morning, and that will continue into the afternoon as these little kinks in the flow, these little shortwaves move through. So that is what is, if we had a much stronger cap, wouldn't be too concerned about all of this thunderstorm activity early on in the morning, but we don't have that strong of a cap to deal with, or to work with, so we may see a little bit more thunderstorm activity going into the afternoon hours. This is Lamont, Oklahoma. Again, that moisture quality, that depth of the moist layer is very, very limited here across northern Oklahoma as well. A little bit of elevated instability perhaps, but that is not all that favorable at first glance for severe weather. But we should see, we're just going to have to pay attention to how much these dew points mix out going into the afternoon, and we probably will see at least a little bit of, if we do see mixing, we probably will see a little bit of compensation from the low-level warm advection as that weak surface low tends to take shape here, and those low-level winds strengthen and back slightly going into the afternoon and evening hours. So let's go ahead and take a look at some model data. This is the 12Z NAM hot off the press, just coming in right now, and this will really show what we're talking about here. This is the initial shortwave here moving through. This is 15Z, 10 a.m., 18Z, which is 1 p.m. So you see this kink in the flow. This is at 18Z, 1 p.m. This kink in the flow, that is a shortwave that is moving through about midday or so, about lunchtime or so, across, and it's located across central to southern Oklahoma. Now, that is mistimed. Usually you want to see that short wave come through right about peak heating, and that's when we see our main round of storms. But because this is coming through a little bit early, that is what may set off another round of storms across central Oklahoma going into the early afternoon hours. But this wave back here, you see this little kink back here, this is our secondary shortwave that will be our initiating mechanism for the main round of storms going into the late afternoon hours today. So again, because we have subsidence on the backside, of this initial shortwave, we might worry about getting storm development later on, but because we have this secondary forcing mechanism, that should negate the subsidence on the backside. It's that destabilization on the backside of the morning storms that could be of concern. By 0Z, you just see it's a very subtle flow pattern, few little kinks in there helping to possibly initiate storms here across western Oklahoma, but just a belt of enhanced flow aloft, 30 to 40 knots of flow here at 500 millibars, not your deep digging trough that you often see in spring that initiates your tornado outbreaks. And that we've talked about before, why my eyebrows always get raised on these kind of subtle flow setups, because the flow is subtle. That means you're not going to see you're likely to not see a ton of updrafts go up along your initiating boundary, assuming your flow is perpendicular to that initiating boundary, which it is. That dry line will be mostly north-south. We'll take a look at that in just a second with your upper level flow mostly going perpendicular to that initiating boundary. Should help storms remain discrete for quite some time as they initiate late this afternoon into evening. Going down to the surface, we will expect to see a fairly weak surface pattern, but again, a little bit of that surface low development out here across the northern Texas Panhandle. Perhaps you see a little bit of a closed contour there across the northern Texas Panhandle and some backing of the flow. And I'm going to zoom in here just a little bit to our southern plains sector so you can see this better. So a little bit of a potential frontal low there, a little bit of a pressure tongue kink in the flow right there. That is the location of a warm front, leading edge of the best moisture return, and a little bit of backed flow right along that warm front. So if any storm can ride along this boundary, it would have the greatest chance of producing tornadoes. But again, we're still questioning whether or not robust enough storms will fire across western Oklahoma for that to come to fruition. But nonetheless, we do have this warm frontal zone in place. You see the wind shift across it, surface winds to the south, out of the south, winds to the north of that boundary, out of the southeast. So definitely an increase in spin and low-level shear along that boundary could be an impetus for storm development or for tornado potential with any supercell that rides along that boundary. Dew points here, you see as we progress into the afternoon, you see that plume of 60s dew points. It's just kind of patchy across southwest Oklahoma into central Oklahoma. We do see some increase in moisture out across this area going into the afternoon. This is going to be a little bit too high, 64, 66, 67 dew points here across central to northern Oklahoma. That is just too high for sure. We don't see any evidence of mid-60s dew points here anywhere. We do see 66 at Childress, but again, mostly in the low 60s at best across this area. That is what is going to advect to the north into this region. So, and if we do get some mixing, those will drop down a little bit to maybe the upper 50s to low 60s at best, maybe 61, 62, 63, maybe 64 at best across this region, all going to depend on the degree of mixing and how much sunshine occurs on the backside of these early rounds of storms. But upper 50s to low 60s dew points still adequate for a severe weather threat, but if we do get some sunshine on the backside, as the NAM is showing those temperatures warming here across western Oklahoma into the upper 80s, let's take a sounding here at 0Z just to show you what things are going to look like. And I'll show you the surface temperatures here, 88, 89, 90s down here in northwest Texas. So this is what we're going to be dealing with here. This is at 0Z, western Oklahoma. We do see quite a bit of instability. Mixed layer CAPE up above 2,300 joules per kilogram. So mixed layer CAPE is definitely looking pretty good for robust updrafts. And that is why we're going to see a hail threat as well. Robust fat instability near the freezing level, which is right about in there. You see a little bit of a fatter CAPE right in that area with limited low-level shear. Not a ton of turning in the low levels as far as low-level flow goes. That is a classic combination for some large to significant hail. But nonetheless, very large instability, but these temperature dew point spreads are on the higher side, 87 over 62. Again, we always talk about the NAM cool bias. 87 degrees may be a little bit on the low side, depending on how much sunshine we get. Let's see, just for kicks, I'd like to see what the mesonet is progging for Norman today. So Norman, the NWS here, showing an 86 degree high temperature, so not all that bad it looks like here for western to central Oklahoma. 87 over 62, pretty good prog here from the NAM, it looks like. Dew point's about 62. That sounds about right to me. So that would produce about a 25-degree temperature dew point spread. We've talked about this before. That upper threshold for tornadic activity, especially on the lower elevations, tends to be about 20 degrees Fahrenheit between the temperature and the dew point. We're seeing a little bit higher there going into the late afternoon hours today, 87 over 62, and even worse down to the south. I'll show you a sounding here across North Texas, where temperatures are expected to get even higher, up into the 90s, where that full insolation is supposed to happen. Full surface heating. You see even higher temperature dew point spreads down there, 92 over 62. That's a 30-degree spread. That is extremely high, and that will definitely negate the tornado threat and tend to produce more outflow production with these storms, especially with southern extent. But right about 0Z or just after, those temperatures are going to cool. We still may have a discrete mode ongoing with any storms that do fire here across western Oklahoma. So if those can stay discrete as temperatures cool down into maybe the low 80s, we'll get those temperature dew point spreads down to about that 20-degree mark, and that is going to be our window for tornadic activity, maybe from 0Z, 7 p.m. or so maybe 6, 7 p.m. to about 9, 10 p.m. As the photographs are at least somewhat favorable. Still not a ton of low-level shear. Let me actually take a photograph. Let me take one right along the warm front here. We'll see one right along that warm front. So any supercell, again, that can ride this warm front is going to have much more low-level shear to deal with. And you see here a little bit cooler along that warm front, a little bit of a temperature gradient across that, 84 over 66. I think 66 is a little high, maybe 63, 64. Moisture tends to pool a little bit on those frontal zones. So maybe 84 over 64, which is about a 20-degree spread with much enhanced low-level shear along that front. You see much stronger veering of those low-level winds with height, approaching 400 meters squared per second squared of effective storm relative helicity. This is a tornado-type sounding, assuming we can get those temperature dew point spreads to be more manageable near that 20-degree mark. This is much more favorable for tornadoes. So I think the main tornado threat is going to come from any supercell that can anchor to this warm frontal boundary. That is going to be the greatest threat for tornadoes. Down to the south, a little bit higher spreads, and especially in northwest Texas, much higher spreads. So the threat for damaging winds and large hail will be greatest there. Will be greater than the tornado threat there. It's going to be a very, very minimal tornado threat across southwest Oklahoma and northwest Texas because of those high spreads and weaker low-level shear away from that warm frontal zone. But generally to the south, you see at least weaker low-level shear and decently strong instability there, especially near the freezing level. Classic combination for large hail. Let's take a look at some model data here. Actually, I told you we would look at the storm mode considerations here. So this is going to be your dry line / frontal boundary here, that pink line. And you see your shear vectors are oriented very much perpendicular to that dry line, almost perfectly perpendicular to that frontal zone / dry line. So that should foster a discrete mode for quite some time here. We will see an increase in the low-level jet as we go into the evening hours. That is typical across this area. As that low-level flow strengthens a little bit into the nighttime hours, we should see that storm coverage begin to increase, and we should see a complex of storms develop here, possibly across central Oklahoma. Again, it's all going to depend on how the main round of storms evolves across western Oklahoma. We should, if we do get enough storms to evolve here, we should see more of a cluster or complex of storms to develop with that strengthening low-level flow, and therefore we could see more of a damaging wind threat take over towards central and southern Oklahoma. All right, let's look at some model data here. This is the latest HRRR run. We'll just run through a few of the cams here. Now, this is the latest run from the HRRR, not showing a ton of activity through the day, especially with that second round. We see this initial round. This is our initial round of storms impacting Oklahoma at the moment as we're recording this. We don't see a ton of redevelopment on the backside here, interestingly enough. But on the flip side of that, the HRRR does not develop much here across western Oklahoma along the dry line, and even into North Texas where heating is going to be higher. I think I'm going to throw this run out for sure. I suspect we're going to see more activity in here, especially across southwest Oklahoma and northwest Texas, which is farther removed from the ongoing convection as we speak, and will be stronger heating down here to breach those convective temperatures with the help of the dry line forcing as well. So I do expect more coverage down here in southwest Oklahoma into northwest Texas. I think this is far underdoing the coverage here. And again, this is still in question how much coverage of storms occurs across western and central Oklahoma. But you see eventually The storms that do develop congeal into more of a cluster or line going into central to southern Oklahoma by the nighttime hours. This is by about midnight, 1 a.m. or so. Now, interestingly enough, some of the previous HRRR runs, this is only the 10Z run, so just a couple of runs ago, did have some robust supercell development across central Oklahoma late this afternoon into evening. This is at 23Z, 0Z, and going toward the Oklahoma City metro area, we have a couple of robust supercells here as progged on this model. So the models, the HRRR especially, has been flip-flopping all morning, but we'll have to watch how that plays out going into the afternoon. Let's look at the WRF ARW model. Hot off the press. So you see a little bit of redevelopment here behind the morning round of storms. So that we'll see what happens here with the, and you not seeing much activity here behind this main round. So even here in northwest Texas, I find that hard to believe. I think we're going to see temperatures get into the low to maybe even mid-90s down here. So not sure why these convective allowing models are not showing, are pretty absent as far as storm coverage goes, especially across northwest Texas. I can see it up here in Oklahoma where we have a little bit more of a conditional threat because of the concerns for morning convection, but very surprised we're not seeing any convection down here in northwest Texas to far southwest Oklahoma. How about the NSSL WRF model? So a lot of convection developing through midday. This is 18Z, 1 p.m. Not much behind that. There's plenty of room behind that. Does try to develop some more robust convection here, especially across northwest Texas. Oklahoma, a little bit more of a struggle to get storms up there. And then we eventually see stuff develop across central Oklahoma late night when the main forcing moves in and the low-level jet ramps up, converges into more of a cluster there. So interesting spread here among the cams. This is the FV3 model. Develops convection there. Does develop some robust storms here from central Oklahoma down into northwest Texas, with quite a bit of clustering there going on into the evening to nighttime hours. So interesting that the cams are kind of still all over the place. This is one of those days where it's going to be a look at the satellite and surface obs type of day to really see how things progress. The satellite is going to be key today. If we continue to see clearing behind this morning round and not too much redevelopment, I suspect that we will get those temperatures up into the mid to upper 80s, in the mid 80s at least here across western and west central Oklahoma, and we should see a supercell or 2 or 3 develop along that dryline / frontal zone across western Oklahoma and move to the southeast going into the late afternoon to early evening hours. Again, across northwest Texas and southwest Oklahoma, temperatures should get a little bit higher, farther removed from the ongoing convection. Therefore, we should have a better chance of heating that area up into the perhaps into the low to mid 90s. So we should at least breach those convective temperatures, and it should be much easier to get robust convection down here, especially across northwest Texas today. Again, temperature dew point spreads down here are going to be higher, so the tornado threat is very close to zero, large hail and damaging winds. But the tornado threat up here in Oklahoma hinges on how much development we can get with this main round along the dry line late this afternoon into evening. So still up in the air. It's definitely a day where you need to be looking at the observations and the satellite data to give you the best idea of what's going to happen. Again, we have currently a slight risk, level 2 out of 5 for the area in yellow here, extending from Ponca City, Enid area of northern Oklahoma down through the I-35 and I-44 corridors into northern Texas, the entire Oklahoma City metro area, and the western portions of the Dallas-Fort Worth metroplex under the gun for that greatest severe threat for today. All hazards on the table. Once again, we do have that tornado threat, 2% risk here centered on central Oklahoma. Again, all going to depend on how much storm coverage develops here across western Oklahoma along the dry line and moves into central Oklahoma this evening. And any storm that can anchor to that warm frontal zone across north central to central Oklahoma will have the greatest threat for producing a tornado, especially as those temperature dew point spreads come down closer to sunset. Farther to the south, not much tornado threat given those higher temperature dew point spreads and weaker low-level shear down there. Large hail, again, going to be the main threat today, given robust instability aloft, especially near the freezing level, and weaker low-level shear away from that warm front. So with southern extent especially, large hail should, perhaps significant hail, is going to be an issue today, and damaging winds. We could see damaging winds, especially as those storms congeal into more of a complex or line towards central and southern Oklahoma and north Texas, going into the evening and nighttime hours as that low-level jet ramps up. So that's going to do it for this video. Thanks for watching, and we'll see you in the next one.